Welcome again, Michael here at Wickerson Studios. I spent some time on the last file, 41, I think 40 and 41, going into the data metas, really starting to see the complexities of bringing out all of this wonderful stuff, and also getting in there and trying to generate metas. So I'm going to leave that, and I'm just going to leave that file there with things up and running. I don't really have a video to go alongside of it. It still has to settle into my head as a new concept. But let's go into something after that, after the data metas inspection I kind of left as well. Inspecting assistance, inspecting data types, I guess, inspecting validity. These are all tests, fairly simple. But I left the text as well because I'm not using that a lot in Grasshopper. I used a little bit with robotics. But I like to get into something a little more familiar, which is vectors. So nothing too strange. We're just going to go through each one of these tabs and get it up and running and associate this file with it. So you can just download this file and you'll see everything up and running. This is the way I kind of come to understand it. So vector from 2 points, pretty simple. Went in, generated a point, which came out of here. Just drag that down. And then I thought, why not make a Cartesian point, because the very next point to make is a Cartesian point right there. So that would be nice, and you could kind of this attributes that would drive that geometry. So you can see how if I took a look at that point, which is kind of hard to see from the complexities of all this, I'd have to go back into here. That little point there, I'm just going to throw a little red tag on it so it can be seen. You can see that I have pretty good control over that point, doing whatever I want. And in the meantime, the vector 2 points is operational. There's a perpendicular to it, which is nice. So it generates a second vector from it as you're playing off. So you see the perpendicular matches, kind of like solving that old cross and dot product type stuff. That's a nice node. And then dissecting the point is really just deconstructing point. It's nice to use the word dissection, and then creating a vector. Again, a vector x, y, z can come from that. So not too hard, not too complex, but you're like, well, why is this model so complex? I also decided to put it on the xz, but you could go in here and vectors. You could choose different vectors rather than that. I think it's under planes, yeah. Instead of XY, I used XZ world. But we'll get there. We'll get the plane, but we're probably going to touch on points and planes and fields as we go. Field would be interesting to generate all these point fields, which I'll get into, but I'll show you that I actually generate a field just from vectors to make it simple in this analogy. So here it is. Going through, I decided to look at vectors from angles. I thought, well, why don't we just create a range of vectors from XY, which would have the power of rotating all the way through the 360 degrees and having 100 points. And then I can control that on the width of what that circle does. And of course, this thing, I need to put it into a color. We can see the green here. There it is, kind of a cone of vectors that I'm able to kind of drive tight in a way. So that's kind of easy as well. I like the kind of color notation. I kept it in the YZ plane. I guess we could put it in the XY plane, and that would just force it up. Let's see what happens when I do that. Yeah, there we go. We just force it up in another direction, which kind of defaults all my other stuff. So you see how it tightens and loosens. And I think I'll put it back to the other one because you can kind of see how it was generated in perpendicular view. Then vector from fields. I thought, well, fields are really just vectors, so I'll just multiply those through a sine so I can kind of make those extend out. So if I take this one, and there it is as orange, and I want it extended out through kind of a sine, 0 to 2 pi. That's kind of how I kind of think about radians when dealing in sine. That's a little playful. And then I guess what I did was just grab those points that were these initials coming from this vector, point origins, and I thought vector from tangents would be nice. And I got into here and did something with the vectors from tangents. What was I doing? I was playing around with just sliding it from one way to the other in the tangents. You see, you can start to play off of that. It's not too exciting because the curves are kind of, the vectors obviously aren't behaving like curves, or that's just the way it goes. And then I flip the vector to go this way, and then I've resized the vector, which is like an amplification of the old Grasshopper one. And then I rotated the vector and decided to put it through an axis of this. What did I choose? I chose an X direction for the rotation. So you see I have a little bit of control at dipping it down. And then those points I can dissect the vector, which is deconstruct the vector from Grasshopper 1. I can find the angles between everything. I can find the angles between 2D if I set it to a plane. That will give me those solutions. And then I can also find the vector relation, which is what is the answer to this? Whether the vectors are parallel within the angle tolerance. So it's a Boolean true or false. And that's it. What is, what it isn't. So the angle doesn't really do too much in this one. I guess that would be the angle tolerance, angle threshold to what I have. So I've set it around 45 degrees. So obviously it's true. I wonder if I take it way down. Yeah, it goes to false when I get to 0. Anyway, that's everything in the vector node up and running. The vector tab, just play with it, get your head around it, make a model so you can kind of study, because for those that like data visualization or visualization to understand how these nodes work and it's visual programming, that might be a great place to start. And in 5 minutes, 6 minutes of that, I'll go into points and I'll continue that, maybe draw some vectors to do it, but you'll see there's a little more elaborate names in here. And we'll get everything up and running here as well, all the way down to end dissect point and end point, which I need to figure out as well. Thanks for watching.